Hi everybody, welcome to this tutorial on how to draw trigonometrical graphs. And we're going to start with drawing the graph of y equals sine x. It'll ask you to draw this graph for values probably between 0 on the x-axis and 360. Okay, so it'll say, the question will say something like, draw the graph of y equals sine x for x values between 0 and 360. It would probably expect you then to know that you need to go up in increments of 90, 180, 270, 360. So we're focusing in on this part of the graph. So to draw it, let's start, okay, by working out what y will be when x is 0. So y is equal to sine of x. So if I put a 0 in there and use my calculator, sine of 0 equals, well, you can try this on your Casios, but I'll tell you that the sine of 0 equals 0. So when x is 0, y is 0, which is that point there. Next value, 90. Okay, what happens when x is 90 and I put 90 in there instead of x? Well, the sine of 90, get your calculators, try it. The sine of 90, it comes out to be 1. Next value, 180. The sine of 180, put it on your calculator. Again, the answer is 0. Then we move on to 270. And the answer is -1. And our final value, the sine of 360, so when x is 360, y is again equal to 0. So let's plot those points, okay? Our y values go from 0 up to 1, back to 0, down to -1, and back to 0. So whereas my scale here is going up in 90s, the scale here, I guess, all I'm going to need is from 1 up there, down to, and again, this is only a sketch, down to y -1 there. So we've put the first point on. When x is 90, y is 1. That's approximately there. When x is 180, y is 0. 270, y is -1, approximately there again. And when x is 360, y is 0, so back to here. So we go up, down, all the way down, and back up. But your sine curves and your cos curve both have a sort of wavy feature to them, okay? So rather than being sort of triangles up, down with straight lines, what we're going to try and do is curve round one way into that one, and then this won't be perfect, but down to that one, and then we curve in the opposite direction, curving round and back up. Not perfect, but it gives you an idea. Now, it normally asks for between 0 and 360, so this would be your workings out. But if you have to continue it in either direction, it's just going to keep repeating. So the next number there, after 360, if I go up another 90, would be 450. And they would go back up to 1. And so that pattern would continue that way. And in this direction, we're coming down here. So at -90, it would go to -1 and back to 0. So we've got that curve. Not the greatest curve, but it gives you an idea of what the sine graph should look like. Next, we move on to the cos graph. So now we're going to have a go at drawing y equals cos of x, the cos graph, instead of the sine graph. It's the same setup. I've still got an x-axis that's going up in 90s. I'm focusing initially on the from 0 to 360, including all these values here. I've left these on for a minute, my 1 and -1, from when I just did the sine graph, hoping that those are the same kind of numbers I might need here, but we will check. Only difference this time is onto my calculator to check it. I'm going to be putting in cos of 0, cos of 90 to work out what the corresponding y values are for these x values here. So I start with the cos of 0, and it's not 0 this time actually. The cos of 0 is 1. I then put in the cos of 90 into my calculator and equals. That's 0. 180 is -1. 270 is 0. And 360 is 1. Same numbers, but with a sine graph, they went 0, 1, 0, -1, 0. This is just kind of, it's like the pattern has shifted over 1. So we're starting with 1. So we're starting up here at 1. At 90, we're coming down to 0 here. We're coming down to -1, back up to 0, and back up to 1. Okay, again, it would be quite easy if we were drawing it to just almost do a V, but that's not what we're looking for. We're looking for this curve. Okay, so in fact, it might be useful to actually put minus 90, the cos of minus 90, and realize that that is 0. So effectively I could start it there, and I'm coming up to 1 and curving one way, then curving back down and round and up and round. And again, it's not perfect, but the exam is looking for a sketch just to show that you appreciate that it's a wave rather than straight lines here, going between 1, 0 and minus 1. If I was asked to go further, maybe start at minus 180, it's not normal, but again, that would curve that way, and again, this would continue the pattern and come back to 0, and that this wave would just continue looping up and down. So that is the cos graph. 1 to go, and we'll come back for the tan graph shortly. Okay, and finally the tan graph. And I've cheated a little bit because I've drawn it before we started, because I don't trust myself to get it right live. But let me explain what's going on. You can already see it looks nothing like the cos or sine graph that we've just drawn, okay? So we're drawing here y equals tan of x. Let's start exactly like I did the cos and sine graphs, though, by putting some of these values between 0 and 360 in 90-degree increments, putting them into my calculator. Tan of 0 comes out to be 0. You try tan of 90 and you get an error. Does not exist. There is no tan of 90, okay? But when you put 180 in, it goes back to 0, back to error, and back to 0. In other words, there is no tan of 90 or tan of 270, or the next one would be 450. It does not exist, okay? So to show that, I've drawn dotted lines at the points it doesn't exist, at 90, at 270. I could do another one there, okay? Now, if we were to put a few different values for x in, starting with values near 0, like 1, 2, and then some values maybe nearer 90, like 88, 89, what you'll see is this starts growing quite slowly, but the closer you get to 90, it exponentially grows. It gets high quite quickly. So if you were to try something in your calculator, like tan of 89.5, 89.6, 89.7, something like that, you'd see that the numbers get fairly big. Not 1 anymore. We're talking some pretty big numbers. Whereas if you then jump the other side of 90 and did 90.1, 90.2, you'd get some pretty big negative numbers. So if we're going from pretty big positive numbers to pretty big negative numbers, but right on that point, there actually isn't an answer. So the sketch looks like this, okay? It comes from 0, starts growing slowly, then quickly, but never gets to 90. The other side of 90, it picks up on a very negative number. Don't have to put a scale here, okay? Starts growing quite quickly, then it slows down, then starts getting quicker, never gets to 270, and then it picks up again. So you get this, it is like a wave, but it's a broken wave. It waves around, stops, starts again, stops. Your best bet here is to almost learn this one off by heart, I'm afraid to say, okay? Yes, this can remind you what to do, and you could do that in the exam to kind of help you and to trigger your memory, but you've got to kind of have an idea of what this looks like, I guess, before you start drawing it. The good news about this is it's not as common as drawing a sine or cos graph, because it's hard to follow this up with a part B, whereas the sine and cos graphs, if you're drawing either of those, they could ask a part B, which we're going to come on to next to end this video. Okay, so we're going to move on to what a part B in this question could look like if we're given a part B, that is, okay? So part A has asked us to draw one of these graphs, y equals sine x, y equals cos x, y equals tan x. Again, I think I've probably said this already in this video, you're only probably likely to get a part B if it's sine x or cos x. That allows you to move on and try something like this question here that we're going to have a look at in a moment. Tan x, as long as you can sketch it, I can't see too much being asked about it in a WJC GCSE paper. So this question, here's my part B. Just to say, my part A was to sketch the sine graph between 0 and 360. Refer back in the video if you're not sure how to do that, but I've used a little table, I guess, and I've got my values here, 0, 1, 0, minus 1, 0, and continued that wave. Okay, part B says, find all solutions of the equation sine x equals 0.766 for x values between 0 and 360. So anything greater than or equal to 0 or less than and equal to 360. In fact, what they're trying to say is all the x values between here and here, can we find solutions of this? So where sine x is 0.766. Okay, my answers when I did sine 90 was 1, sine 180 was 0, and so on. But where would I get an answer of 0.766? Well, roughly, this is only a sketch. You don't have to do this accurately in the exam. Roughly 0.766 is that. Okay. So if I want to find my answers using this graph, I'll go across, and that value there would have given me an answer of 0.766. All right, 0.766, let's write that there. But a continuation, and apologies, not a straight line. I've got another answer there that will give me an answer of 0.766, whatever this value here is. And if I continue that line over, I've actually got another answer over here. And if this wave continued, I'd have more and more, in fact, an infinite amount of answers, okay? But I'd also have answers in this direction if the curve continued this way. So bear that in mind for questions as well. Okay, however, I'm not going to use the graph for a second, because if I was asked to solve this, I wouldn't need a graph to solve it, okay? What I would say is, if sine x equals 0.766, to find what x is, what I need to do is take the sine, much like I do in trigonometry, in SOHCAHTOA trigonometry, or cosine or sine rule. If I'm finding this angle here, I would take the sine over as sine minus 1, 0.766. And if I put that into my calculator, I get the answer 50 degrees. So I've managed to get an answer to this without even using the graph, just using my algebra skills and my calculator. However, if we go back to the graph, my first answer when I came across from 0.766 was here. All right, roughly halfway between 0 and 90 on my sketch. Now that answer must be my 50-degree answer. Now, unfortunately, a calculator won't give you the next answer. A calculator can only give one solution. So if I want to find this solution and this solution, I have to use the symmetry of the graph. So if that is 50 degrees from 0, that line there will be 50 degrees back from 180. So this one here is 130 degrees. So here's a second answer. X equals 130 degrees. Or, again, just like my graph starts there, over here it starts at the same place. So this must be 50 over from here, which is 410. Sorry, you can't see that. That's a bit messy. So x equals 410. And there are other solutions that we could find over there and in this direction. However, we are only asked for solutions between 0 and 360. So 50 is a solution, fine. 130 is a solution, fine. But actually what I've done here is I found a solution past 360, which is 410, which in this case, I don't need to give them. It's not wrong, but it's not within the values that they are asking for. Okay, you'll have a chance now to try some of these, a chance to sketch some sine, cos and tan graphs, but also to have a look at some of these part Bs where we use algebra to get one answer and then the symmetry of the curve to find other answers. Hope that helps, guys, and catch up with you soon. Thanks.